Okay, so second part for this is a failure theory. So this one is a new things. You will experience quite a lot of formulas, but don't worry, we just listen first. Then we will go through an example later on. So failure theory. So we need to have a testing machine to test the part, and we will get the data. Okay, how to measure the part that up to the failure? How to measure? So it's very important. We need to identify that what is important. The criteria is the critical stress. Where is the critical stress? Where is the critical strength? And what is the critical energy? The most important part. But until now, there is no one theory can apply for all. There is no universal theory for all the case. Everything is a prediction. We will prediction for this case when it will be happen, and what theory to use, the outcome will be different. Okay, as we know, we got two types of material. One is ductile material, one is brittle material. So ductile material, you will go through the yield. So you will become elongation, afterward only fill. If brittle, you will not go through the plastic range, then you directly fill. Okay, so this is the two different criteria. For ductile material, you got three theory for that. Brittle material, you also got three theory for that. But we will not go through everything. We just go through some only. Ductile material are normally classified with the true strength more than a value. This is the value. Okay, so we identify it when the extension or compression is the same, or the value is the same. Yield strength, yield compression, or yield is the same value. So this one is the criteria. If these two is happen, so that is we apply these three, one of these three theory in ductile material. Okay, and the true strength is more than 0.05. What if the value is 0.05 less than that? So that will be in brittle material. Okay. Okay, now we go through two theory. One is MSS, and another one is DE. Okay, MSS and DE. So MSS, maximum shear stress. So for ductile material, this theory to predict that the yield will start to happen at the maximum shear stress. If the element is equal or more than the maximum shear stress in the tension specimen. So we got a value for that. For the testing specimen, you more than that, more than the value, you start to yield. You start to yield. Most of the time, the crack criteria, you will go through approximately 45 degrees with the axis. Okay, you will crack it 45 degrees. So this is because the shear stress will be happening in 45 degrees at that condition. Okay, so here is some of the condition of the formula. So the maximum shear stress has happened at the 45 degrees for the tension surface. So the maximum shear maximum is the stress divided by 2. And the yield is happen, shear maximum is Sy over 2. So this is the three principal stress as can be happen. 1 more than 2, 2 more than 3. Okay, so it's generally want to predict the yield when this happen. Shear maximum, first one minus the third one over 2. So still remember the principal stress, the theory for principal stress. Okay, this one is you learned before lah. Okay, stress 1 minus stress 3 is more than Sy. Okay, this is the first one. So if the yield of the strength in the shear in this value is Sy, SSY equal to 0.5 Sy. Shear yield, this one is yield. Okay, it's a little bit difference. If you more to consider shear maximum, is SY divided by 2N. N is the factor of safety. This one we will use it to calculation. So our main purpose is to calculation for factor of safety. How safe for our part. Okay, so everything will be happen in three-dimensional state of the stress. So basically, for this theory, we classify into three cases. Okay, so if it happen in the principal stress, okay, from the value of the calculation, stress A and stress B, we convert into the principal stress. What if the case 1, stress A and stress B, A more than B, B more than 0. So stress 1 equal to stress A, stress 3 equal to 0, stress 2 equal to stress B lah. So this happen. If A is between 1 positive, 1 negative, so stress 1 is stress A, stress 3 is stress B. So this will be happen. Okay. So if all less than stress A and stress B both is negative, this case will be happen. Okay. These three criteria. Okay. That means all the value that you get it from the part for the stress A and stress B, we convert into the principal stress for calculation. Okay. So the maximum shear stress theory, this is meant to predict the yield if the stress state is outside the shade region. So it's like this. So you see, this one, the x-axis is stress A, stress B is this axis, so the shape will be like this one. So in case A, both is positive. Case 1. Case 2 is 1 positive, 1 negative. Case 3 is both negative. So it's applied to these three cases. That means if you are, let's say you apply a material, a product from 0 increasingly going up, when you're going to point A, within this region, you still safe. When you go to the B, it's a borderline for the theory for MSS. So this shape is the protection within the all this value you are safe. More than that, you going to fill region already. So this shape is to predict the stress element when we are going to yield. Okay, this is the borderline for all these three cases. Okay, so this all is MSS.